data is very, very important property. And I mean, after some times, or probably you are already working for some companies, some government institute, or in all like these things. So you will have to access, you will have to have access some kind of data, and you should not share all those kinds of data until you have full right to share all those things. So this is very, very important, particularly in this era of data science, when data breaching is a very much important issue. I'll just start with one example how sensitive data can be. So I was working in Singapore Medical School. So I came to know one of the data breach, I mean, some kind of or data something related. So there was what happened there. So there was, the data was de-identified. So no name was there, no passport number was there, but the PIN code was there. Okay, the PIN code was there. And in some country, like if you have a PIN code, that is the exact address of a building. Okay, now suppose there are some sensitive information, like it could be like HIV infections, or even like the something related to the coronavirus infections, all those kind of things. So now, if you have PIN code and there is only one person infected with particular virus, and with the, so name is not there, but ethnicity, like whether Indian, Chinese, American, or Caucasians, and all those information are there. So you can boil down to things that will pinpoint it. Oh, look at that. That is the person who is infected. So that is also kind of like issues that you need to deal with. That means that sometimes we vaguely think about that just we remove the names and the passport number or identification numbers, that data sets become de-identifiable. You cannot identify it. But it's not like that. With a lot of other information, you can actually pinpoint it out who is the person. Okay, and a lot of people work on that, how to make sure that your data is really de-identified, and it should, so that you cannot trace back the person who is there. Okay, so as a data scientist, you may again and again come with these kind of things. So never mind, we'll start with the attendance data that we have already seen. So I will do the exactly same analysis that we have done. So the purpose is that because we are running in a very short span of time, so if we fluctuate too many data sets, you might just get lost, so that we will focus in a single, I mean, only few data sets, so that you at least you are accustomed with whatever is going on, and so that you are motivated enough to do the things by yourself from your end. Okay, so when I started, so this is the like RStudio background, and if you have installed RStudio, so you are pretty much done. So whenever you start RStudio, I'll first write the get wd, so get my working directory. So it's a long directory here, and sometimes if your program is not in that directory, what you can do here, you can go to the session and set working directory to the source file location. So it will automatically fit that to the particular work directory that I have here. Okay. So I'm working with this one analysis of the attendance data, and for R, these are the different packages that you can work. So package means that somebody already developed some functions, they are condensed, and they are very useful for doing so. You don't have to do a lot of things that really already taken care of in that package. So I will upload that or I will call that one. So if I press here in the if you press just Control Enter, so it will automatically call, so that I can use the whatever function already built in ggplot function. Okay, that's fine. Now, so if this package is not installed, what you can do, you can go to the packages here, install here, and write ggplot2. So you can just click here and press install, then it will be automatically installed for it. For it is not only for this package, for any other packages that is not here, you can install that packages for you. Probably most of you are already familiar with them. And R is very much flexible. You can do a lot of things. And compared to the last 10 years back, so when R started, I mean, right now the R is one of the extremely famous language all over the world, and you don't have to pay anything for this art. You can just download and straight away start working. Okay, so what I'll do, so since I set my working directory in the where I have put the data sets, like this is my working directory, all the data sets are here. So I'm not going to give any path here. Otherwise, you have to put the path, exact path. So I'm writing read.csv here and your file names in the quotations. I'll just run this one. You have two options to run this one. Either you just place your cursor here and go to here, run. So it will run only this point. And if you run this one source, it will run the entire file. Okay. Or otherwise, put the cursor here, just press Control Enter, then it will run again. So that means that dataset is already read by R and it is stored in DD. Okay, so whenever you are working with some computer programming language, don't estimate your importance. You are the most important person in the world, and particularly when you are doing the programming. Okay, so you give instruction to the computer or laptop, and it is based on your instruction. So you should not become a slave of the machine. Make your machine to slave of yourself. Okay. So so think about that, because at any point of time, you should not lose control of whatever is going on. And that's why you need to document everything. So I'm not a good programmer. So right now, most of the things is done by my students. So let me, so anyhow, I just able to write most of the things, what we are going on. Otherwise, after some point of time, you will forget everything, whatever is going on. Okay. So now we'll do the scatter plot as we already done. And this is actually under the ggplot function. So whatever we have written here, we just select this one as like this and then run. Okay, so that means everything is stored in the plot.scatter, and then I will print that one. Okay, so here is the graph, and you can also make it zoom. Okay, so that means this is the graph for you. So this is the days attended and the marks obtained, and you can see that whatever pattern you have already seen earlier, that graph is generated for you. Okay, so let's close this one. Go back to the Art Studio. So personally, I don't like to any commands to be remembered. I generally remember any of the comments because I am not good at remembering things. So generally, whenever I require like I either search how to do a scatter plot. Okay, then I get all the comments and I just copy and paste here and change accordingly. Also, you can just write ggplot here, and it will come here. Just press one question mark and ggplot. So you can see that there will be a lot of information is already given for you, and you can find. So you can read all those things and go straight to the below. So there are a few examples. If you are not familiar, just copy one example from here, change your data sets and other things that you are doing, and you can have something. But a lot of times, or the most of the times, generally you will not find whatever you actually need. So then you need to improvise what is going on. So here I am using ggplot command, and I'm saying that data. So ggplots, please use the data DD I'm mentioning, and this is AES inside that. So I don't remember all those. So if you are not familiar, just search all those things. So I'm passing the X variable. What should be my X, days attended, and what should be my Y. So before that, you can also just put how the data looks like, head DD. So it will print the first few 6 lines. So days attended and the marks. If you are trying something new, you just copy from here and paste here, and copy from marks and paste here. Okay, so this is the scatter plot. Scatter plot is the use to how to see that things are going on. And then I'll go for the regression model. So LM is the code for regression model. So if you are not familiar with the LM is short form of the linear model. Okay. So fitting linear models here. All the useful things are there, and you should able to read all those things like LM. You need to give the formula, data, and there are so many other options. Okay, so you can check all those things, and all the details are there. You can read all those things whenever you necessary. Some basic examples are also there at the end for the all like things. So you can go ahead with that one. Okay, so here I'm calling about the Y and X. So notice that here in general, you have to specify your data, but I am not specifying any data here. I am directly calling. So DD dollar means I will use the data DD, and dollar means that I can specify the column names. So I am calling the data DD, and I am using the marks as the Y variable. Similarly, DD days attended as the X variable. So that is already done. So let's run that one. I'm having this here. Okay, so what is the summary statistic there? Okay. This is the summary statistics here. So I have fitted the formula like DD marks, DD days attended, and these are the residuals, and intercept is 0.004, and the days attended is 1.64, and this is not significant, intercept is not significant, and this is just significant at the 5% level or just less than 0.05. So this is belonging here, and the residual standard error is 11.42 with 20 degrees of freedom there, and multiple R square is 0.18, which is not good. That means that days, a number of days attended is not a good predictor to explain whether the final marks, and that pretty much makes sense to me and also for you. So as I pointed out, that model is not important. I mean, model is only a tool, and you are applying. Here I am applying a regression model or simple linear regression model to understand that whether the number of days attended has any impact on the final marks. There is an impact because this is a positive quantity, 1.64. So that means if you, as we have seen here earlier, so if you attend more classes, there is a chance that your marks will increase, but it will not able to explain everything, because as we've seen earlier, let's go back to the to the scatter plot here, then you can see that one. Okay. So here you can see that there are a lot of people who obtained, or at least few who obtained moderately high marks. This is close to 70 marks. Okay, even though they are not attending too many classes. So that means there are some things, they may not be attending classes. They may be studying on regular basis, but otherwise they are extremely intelligent. And there are students who are attending most of the classes, but not getting that much of marks. And it may be that on that particular day, the performance of the student is not that good. So there are a lot of factors. It does not mean that that student is good or bad based on that particular one exam. That means that maybe means that that particular day of exam is not good for that particular student. So the thing is that at the bottom line, with respect to this regression, I can say that the let me go back here. Yeah. With respect to this much of R square, number of days attended is able to explain only 18% variability that that is existed in the marks. So whatever the variability existed in the marks outcome, or the output, that is only explained, 18% of them is explained by the days attended. So there are other factors. So more information is needed to build a more valid or accurate model. Okay, but nevertheless, this model is not that bad, at least with respect to p-value is significant is there. That means there is a significant impact on days attended on the marks obtained. Okay, so let's see what else. So diagnostic plots, let's check that. So you see that there is an error because there is no space to put the graph. Okay, I will run this once again. Again, the same thing. Let's make the area a little bit larger. Control Enter. Yeah. So we got that. results here. Okay, so you can see there is a certain, it's not like exactly random, but this is also a very small kind of data, and normality assumptions is not exactly fine. There are still problematic area here and there also, but there is also the Cook's distance. So here, that means there are some at least leverage point which actually potentially bringing the regression line towards them, and this kind of observation can be problematic. Okay. So far, so good. Now, I'm done with this data set. So if you want to run that data set from the source file, you have to just do this source here. Then it will run all these things. And because of there are a lot of figures and this area is problematic, that's why these are errors, but it should not be a problem. Okay. All graphics problem, but those everything is already plotted, I think. Okay, any questions out of this one? No questions? No question means either extremely good or extremely bad. Okay, never mind. We'll go to the next one. So the second one, these data sets you should have. Do you have these data sets? Hello? Do you have these data sets in your folder? Height, mother, daughter.csv?
Yes, sir, we are having. Yes, sir.
Yes, sir.
Okay, so right now, can you write all those things from your end so that at least we can do at least one regression analysis from your end to make you feel good about the whatever is going on. So you need to write that read.clv height. So if you want to write that, go to the file or just below, you click this one, click R skip there. Okay, and here I'm just copying and paste. So copy here and paste here. I always put some gap in here so that it's become readable. And once you put that one, okay, so if you are running first time, go to the session, set the working directory to the source file location. Or it is not saved, that's why it is creating a problem. So, but here, if I run from here, it will not be a problem. Okay, or I can feed the session source location file. Okay, I'm again running that one, and okay, just if I write head here, I will have these data sets like this one. So has any one of you able to run this command from your end and read the data? No success?
Can you post the code right in the chat box, sir?
Okay, so you don't want to write by yourself. Generally, writing there will be helpful. I don't know how to put that one because otherwise for the grid, okay. Chat box, yeah. You need the source code file, so you don't want to, you just need everything. Yeah, I'll share the source code, no problem. But if I share this, you will just do not do the everything from your end. Let's try at least one, then I'll share. So I want to make sure that at least one code, and let's start with this. This is not very long code. So try this one, then I'll share the others with you. Are you able to read that file? Any one of you? Okay, fantastic. So now, because sometimes whatever you need a data set, and I don't need this number. So keeping only 2 columns relevant. So if you can, I'm again sharing. So all of you just at least copy paste and run these things. So then you will have a better experience. So I'm just removing this number here. So here, if you just put the up arrow, then you will go back, and again, if you print that, so once I run this one, let me run this one. Yeah, so if I print the head again, then there is no ID column. So I'm just removing those. So this is the command from the hide data. I'm calling hide, but -1 means that don't keep the first column, remove the first column. That is the command for you. And then if you put the head here, this is the one. Okay. So now these are the two commands, or I can, all the commands I can press here. -1 means first column, or minus means that remove the first column. Okay. So if you just want to see what is the, so let's check whenever you have a confusion, you just, okay, right now my data is this one. Okay. So if I put this in, then you will see that what is happening. So I'm now calling the head data, first few lines of the head -1, +1. Okay, so this is the 59.7. So that means if you put +1, that will call the first column. Similarly, if you put the second one, then it will call the second column, 55.1, and so on. Okay, so let me give you all the other chat one by one. Okay, so try all those things. So head is there. Then if you put the summary here, then you can see what is going on there. Okay, so this will give you the idea of like mother height and daughter height, and the str will give you the idea of that we have 1375 observations and 2 variables are there, and m height is a number and d height is a daughter height, that is also number. So why this is very important, because a lot of time you will read that thing, sometimes by mistakes or file format, your these things may be in the character format. Okay, then you need to change the character to the numeric value. So if you are not comfortable with that, just Google it, that how to change character to numeric in R. It will give you something. For getting SD or var. So better, whenever you have questions, just put into the Google. For getting SD and var. So let's take SD of what? The mother site. So that means I need to call the height, HEIGH. Yeah, so height and $sign, m height. This is the SD. If you change, I don't know, remember, let's type the var. Yeah, it's working, variance. So this is the standard deviation, this is the variance. And if you check the mean, mean that is also HEIGST height, $m height, it will give the mean. And I don't know, remember the command for the median. Let's check that. So all these things are there. There are a lot of things, and I am just covering only very small part of it. This any summary report of what summary? Yeah, you just print that summary here. So here you can get all those things. So if you are talking about that whether you can get all those information from summary reports, I don't know whether they can be called or not. You can try. Can I include SD in summary report? I do not have any idea. So, but you can formulate one. So, better thing if you want to specific like you want to include SD in summary report, you need to build up that. You need to build a function for that and include that. Then you can do. But I don't think here you can directly include summary of that one. Okay, so R is very much flexible. Whatever you do not have, check in the Google that whether somebody has already built up or something or like that, or if there is nothing, you can just improvise yourself. It's not that difficult to build all those things. So, but basically, you need to write a function for that one. Okay, so plot. Let's do the plotting here. So again, there is some problem. Figure margin is too large. Make the area a little bit larger for. Okay, run it. Yeah. So actually earlier we have plotted the bar that is 2x2 grid, and that's why it was open there. I need to close that one. It is called dev.off. Then after that, if I run that, then it will be full screen. Okay, you can see that the mother heights versus daughter height. Yeah, someone microphone is on. Are you saying something? Okay, so great. That means that you are able to plot the scatter plot, and we already explained what does it mean. So I will give you this code to you so that you can try from your end and get a feel of that, what is going on. And if you want to save this plot, you just go to the export command. So there are options: save as image, save as PDF. So if you go to the save as, so you can put a file name, whatever name you want, scatterplot something. You can change the file format to PNG, JPG, TIFF, and all those things are there. And you can also change the directory, and you can specify the width. Like generally, if you want a very specific 1200 by 800 is good one, and you can save using this here. So it will be saved in your corresponding files or something like that. Okay, so pretty much simple is there, and a lot of flexibility is there. And R right now the R is extremely good, extremely good. You can do whatever from very basic to an extreme level advanced things you can do here. Okay, and so now if you want to fit the regression line, just try to fit the regression line from your end. I just copy here and paste here for you so that you can write the regression line here. So I am just, yeah, so I have already done. So if I put the summary here, it will be here. And as I always said, so fitting regression is not a big thing. So it's nothing big that you should be proud of that. Oh, I have fitted, I have learned all those things. The main thing is that interpretation and connect to the things with the basic science problem. So when you are doing something that is a basic science problem, and as a statistician or data scientist, you're applying some tool to that problem. The main important is the research questions. So model is only part of that. If you cannot interpret or cannot connect those things, there is no sense of doing that one just for sake of completeness. It's nothing. And how as I'm told again and again, how the data was collected, what are the basic understanding, those are much important. It is not that you have Excel file or CSV file, you just fit the data. That will not give you a sense of the feeling as a statistician. There are a lot of inherent qualities or the data that you need to understand whatever is going on. Only after that you can connect things, and that will be that time you can make inference about the population itself. So you need to understand the basic science of that particular data or of that particular problem very carefully. As I always told my students to, so the data science is only valid when your basic science is valid there. If there is no basic science, doesn't matter whatever model you are working on, how sophisticated your code is, no matter to at the end of the day, it will not add any value to from your point of view. Okay, so again, so here these are estimates, and we have already explained that in the theoretical part. Yesterday about the simple linear regressions, and both of them are like they are significant. And I can see that the R square value is 24%. So it's only explain the 24% of the variability that do exist in the daughter heights in terms of the mother height. Okay, and I cannot see the adjusted R square. Yeah, so adjusted R square is this one, not too much, too far from the R square value. Okay, what else? Here, yeah. So you can write all those things. You can check from your end. Let me paste there the chat box. Okay. Also, so this is called the head of fitted values. Oops. Why there is so much errors? Oh, these are the warning message that sometimes can happen. So if it is not too much problematic, just ignore. Until otherwise it is not error, yeah. So there are some issues like calling something. So right now, if I run it again, it should not be a problem. Yeah. So again, there are two commands. Let me copy that one and paste at your end. Okay. So let me run that one. So it will give you the sigma, and it will give you the R square value. Okay. So if you want to get the coefficient only, then also get that one. Okay, so these are the intercept and the M height. So let me check whether one. Yeah. So you can only call one of them also here and round it up. Coefficient is like that. And the last but not least, the diagnostic plots. Okay, here you go. So let me run this last one. I need to make the area a little bit larger, otherwise it will put some error. Control enter. Yeah, I am getting the value. So you can then, it is perfectly all right, at least practical point of view. So the QQ plot is also fine. The scale location is also fine. And this is also, let me check, I am not able to see this one. Yeah, so there are, okay, this is the Cook distance line. So there are some problems which may be influential. So you need to take care of all those things. So if you are really interested to build up all these models, so there are some points which are below these the Cook distance line. Though those points can be problematic, and that's why you are not able to get a very good R square from this model. Okay, so any questions with these problems? Anyone? Otherwise, we will go to the next one. Any questions or comments? Okay, so then I'll go to the next one. So we are done with the simple linear regression, and we'll do the multiple linear regression right now. Okay, so let me copy it here, and so you should open another script file from here. Just click here, our script, and save it in appropriate name, whatever name you want, and then do that again. So let me something here, copy, paste. Yeah. So sometimes a lot of things can be there. So what you can do that, you can come here, and so all these data sets, so heights.element is there. So what I can do here, just press the clear object from the workspace. So it will remove all the objects. So you cannot, if you call now height, HEIGSTS, so nothing will be there. Nothing is there. So that is already removed. So no log is there. And if you put the control L, just I put the control L, so whatever was written, that will be gone. Okay. So I am again, so now I already removed the D. So I ran that one, but let's check whether D is there. D is not there. If I run again, because I deleted everything from here. So if I run it again, now if I write the D here, then D is there. Okay, let's check the head of there. Okay, similarly, if you want to delete the figures here, you can clear the plots here. So everything is clear from here. Okay, so right now, this is the head command, and I'm just giving you all the comments that I will write here to you so that you can use all those things from your end. Okay, head is that you will have an idea about the head part of the data, and just like here it will print only first few 6 lines, I guess. But if you want to print more than 1, more than 6, just print like this one. Why it is happening? Yeah. So it will print like first 10 of these things. Okay, and this warning is error because I have maybe installed some packages which is conflicting with other packages or something like that, or some unknown, I think, I don't know. So this is print something like that, and for the tail one, if you just do one, it will give you the tail. So all idea is that whenever I start any data analysis, I check from the multiple points of view to understand the data, to get a feel about the data, what is going on. Only then you have idea. It's like when you are entering in a new city, or you are going new places, you try to explore and talk to the local people to understand everything. Only you'll feel a sense of belonging there. It's exactly same when you are trying with the new data sets. You need to look at the data sets from different angle to get a feel of the data set, to understand what is the inner meaning of this data set, so that you can visualize the things, what is going on. Okay, this is the FEV data, this is something, how it might be connected with the height, the sex, or the smoking status, or the age. So all these things will be naturally come to you. Then only you can visualize, and you can make sense something out of that data that you are working with. So this will be give the columns, and str will give you the short form of the structures. So we have 654 observations here, and the 6 variables are there. And out of these 6 variables, we have ID integer, age that is integer, FEV is the number, height is also number, sex is character variable, and smoking is character variable. Okay. Now here I'm making, because I will fit the linear regression and multiple linear regression here, I'm making these character variables to the factor variables. Copy and over. Okay, so let's run that first one and what is happening here. Yeah, so right now if I print again the strd, now look at, this is the factor with 2 labels. Okay, earlier this is character female, 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 male, and all those things. And again, the smoking is again character, it's not factor. I run this one, control enter, and put the strd again, and this also become a factor variable. Okay, this is very important, otherwise your interpretation will be changed. You can try what is happening if you do not convert the character variable with the factor one. In sometimes, I don't know, I mean, some cases it will automatically take as factor variable, but I have not checked that. So it will be your homework to check that. So yes.
Sir, in this, sir, female getting the 1 and male getting 2 while changing the character from character to number.
Yeah, no problem. So are you sensing any problem?
No, sir, I'm asking that I am understanding correct or not. So same that female getting the 1 number or male getting 2, same.
Yeah, it doesn't matter. So that's why I mean, you can code something like 3 or 45, something like that. So that's why when we like call the regression model, you will see that the baseline is not there, but the non-baseline factor is written there. You remember that sex male, that means that variable sex is with respect to male when the female is at the baseline. So R will, when you make this factor, R will store this as a 1 as female and male as 2, something like that. Oh, you are talking about which one corresponding to which one? Is that your question?
Yes, sir.
Okay, I got it. So that I don't know. Let's check that. Table, data name is D, and right now this one is 6, and just enter. Okay, so here I am not able to even, so how to check that one? Specifically, I do not have any answer to that one. Only thing is that.
So we can plot the head, then you can see at least what is allotted to the first one.
Okay, yeah, that is a good option. Let's see. Yeah, female is 1. Yeah, so generally they are written, so logical sense, I mean, I have not checked this one. So logical sense is that female is written first. That means that whichever one is first goes to the female, and since the current is written there, so it means 2. So that here, let me put the tail also, tail D. Yeah. So here, look. So here it is all 2. That means that for the non-smoker, it is actually 1. Okay. Generally, which is the one that is considered the baseline, and which is 2 is the opposite one. Okay. So here female is 1. That means it will be taken as the baseline. Here the non-smoker is 1. That will be taken as the baseline, I guess. Or you have to check. So it doesn't matter. From the year's point of view, you can check from this here. Someone suggested that, very good suggestion. And otherwise, from the regression point of view, it does not matter, because when you print out that LM functions, it will automatically, it doesn't matter whether it's 1 versus 2, 41 versus 42, something like that. Okay. I'm happy someone asked some questions. Otherwise, online teaching is very difficult. I'm talking to the computers or laptop all the time. Okay, so this will print like where, yeah, two factor I have given to you. Now let's copy it and paste to your chat box to you. Okay, great. So far so good. Print this one head, then I will have the head of all these 50 observation. You can change this one. D is the 200th row, so it will print all the observations like the ID, age, FEV, height, sex, and smoking status. So similarly, the D is like 50 to 55 row. So this here is a comma. So this side represent the row and this side represent column. So if I similarly, if I put this one and we just put 1 or 2, so it will print the age. Yeah. So because I am calling the 50 to 55 row, the second column only. So you can explore a lot of other things, and if you are learning for the first time, then it will be a lot of fun from your end. Okay. And at the end of the this discussion, let me remind, I will show you something what else you can do with respect to R. I will give you some examples of extremely good thing that you can think about or you can feel great. Okay, so summary, yeah, summary I have already given to you. So let's graph here and paste here. Okay, so when you put this one, this will actually prepare a 2x2 grid for you to plot all these points. So here, how this is working, this is interesting. If you are learning this first time, already some of you already know these things. For them, it is just a repetition. So if I plot this one, so look, it is created 4x4, but I am just called this one, so it will put here only. If the second one, control enter, so it will put here. The third one, control enter, is coming here. The fourth one is coming here. Okay, so again, I can call all of these things together. Okay, so that means if I run this one, yeah, those things are changed. Okay, now the fitting the linear regression, most important part, and paste to you. Okay, so if I to run that one, have this one. So let me explain again, because I am going again and again so that you are much familiar what is going on. So by this, so when I'm, so this is regression is an object, R object, where I'm putting all my regression output there. If you do not put this one, this will also run. If you just run this part only, it will also run, but at that time it will not store anywhere. Okay. So I'm calling this LM function, that LM short form of the linear model. You can search $ln, and then this is my outcome variable, that is continuous FEV, and these are my input variables, height, age, sex, and smoker, and the data is D. So from the data, I'm calling all these variables. I'm trying to fit a linear model, specifically multiple linear regression model. So everything is done, pretty much simple, easy peasy Japanese. And then I'm calling the summary of the regression here. And when I'm call this summary of regression, it will print the whatever summary it has. Okay, so here, this is the call. From here, you can understand what was the formula if you forget already. And these are the residuals. These are the, so 1, 2, 3, 4. 1, 2, 3, 4 variables, and one is intercept is there. And these are the corresponding estimates. And whenever you look at the estimates, your first observation is that whether what is the sign? Is it positive sign or negative sign? Here, this is the sign negative, and for everything else is a positive. That means immediately you interpret for the variables like height, age, sex, and smoking status, they have a positive impact on the FEV. What does it mean? That if you increase height, FEV will increase. If you increase age, your FEV will also increase. If you're if you compare here, when you are talking about the categorical things, you cannot say that like increase. So I mean, for the categorical status, like female to male, so that's not a feasible thing kind of thing. So what you are saying that compared to a female participants or the female child, if you are talking about the male, so that is the change I'm talking about, from one individual to another individual. So here, when I'm sex male, that means that this coefficient is actually for the male category. Okay, this 1.5 compared to the baseline female. So compared to a female child, if I'm talking about the male child, then there is a, increase in the FEV. So in very lucid language, that compared to a female, a male child have larger FEV. That's all the interpretation in very lucid language. And if we are talking about the smoking status, so in smoker non, so that baseline is the current smoker, from the smoking, someone who is smoking to non-smoking. If I change the status, in this case, you can think about someone was smoking something and now do not smoke, then you can increase FEV status. Also, if someone is smoking and someone is not smoking, we expect a higher FEV value because of this positive sign. But the magnitude is not that great compared to the others, if you are talking about like 0.15 and 0.10, something like that. Okay, but and also this is not a significant observation, so we have not observed, at least with respect to this model, that the impact of the smoking on the FEV significantly. But if we have much more larger data, then we might see something else. Okay, and in all those things are significant pretty much. So very, very small p-value is there. Okay, and R square is 77%. So that means that whatever variability we observed in terms of the FEV, and this particular linear model was able to explain 77% of that. Okay, so this model is pretty much good in this case, because this is not a rocket science that I already mentioned about, but in this case, I'm trying to explain the things with respect to, and in this case, 77% R square can be considered as a very good R square. What else we have? So now with without intercept, and here the only difference is this -1, and as I explained, in this case you will get inflated R square, and which does not make any sense, because when I do not have R square, intercept term, so R square does not make any sense, and it's not a valid measure at all. Okay, so let me put all those things to you so that you can run from your end again. Okay, great. Again, some of the useful commands. Yeah, paste. Let's run that. So again, we are talking about the head. Now you are expert in the head command, and you can print the head of the fitted values, the residuals, you are calling the regression coefficient of the variable 2, that is height. The second command, and then you can also call the coefficient of all the parameters. Okay, with the confidence interval. So it is actually the confidence interval command. So you can get all those things. And there are a lot of other things, and a lot of people have developed different packages. So once you start, you will accustom with all those things, and you can do many things. It's extremely flexible language, and it's highly popular, and you will be amazed how many people are currently working with R at this particular point of time. There are many people are working at this particular moment all over the world in R. at least in this group, at least around 80 people are working with R. As under the assumption, everyone is using R. Okay, so I have copied that one. So let's run that. Yeah. So there is some error, and if you are really interested, you can check all those things, but I'm not going into that line right now. Since it is warning, I can ignore. But if you took in, of course, you can check all those things. Now this is important, and so just copy it, paste to you, and try that one. So I have a new day, new X data. Let's print that. What is new X? Yeah, this is one. And if you want to predict, and paste to you. Okay, so let's run that one. So this is the thing. So you are right now, you have a new observations, and which is the height 61, age is 8, sex is female, and smoking status is non-smoker. For that, using that regression line you already built earlier, your fitted value of the FEV is 2.42. Okay, so this might be very much useful. So suppose that particular female child came to our doctors, and doctors will say that depending if that model is true, say for example, at this point, assume that that model is perfectly fine. So then doctor will say that her expected FEV value is from this model 2.42. Okay. Now, if that girl at that particular time, the FEV value becomes like 2.1. That means that based on this model, the doctor will say that FEV value is not as per expectation or as per the convention, because of that model is set by convention. So it is lower. So there might be some problem with that girl that needs to be addressed. Whereas if it is more than that, then FEV value, and considering that the higher FEV value is good, that will give you the strength of the lung. So if it is higher like 2.5, the doctor says, oh, it's perfectly fine, no problem with that. So to give you the motivation, so all of you know that the blood pressure ranges from 90 to 120. Around 120, the systolic blood pressure is fine. But who told that to doctors? So this is exactly done in the way we have done today. So many years ago, there are a lot of studies, and I mean, from time to time, a lot of studies going on. So they collected the data, they analyze all those data. They might have fit some kind of regression model or some other model. So they see that they categorize healthy people and maybe other people. For the healthy people, I will see that the systolic blood pressure range is around 120. And then there are a lot of doctors discussed about that things when this is the perfect range. So, and they decided that 120 was the borderline that we can take as a normal blood pressure. But right now, because a lot of lifestyle is going changes on in some part of the world, that it is still considered that 130 systolic blood pressure is still good for you. So earlier concept is 120. Now there are a lot of modern data is coming, and the doctor scene or the health scientists who are working with the health data and the statistician, they think that 130 with the 130 blood pressure, people are perfectly all right. So then they decided, some documents says that I can consider 130 is still good because we are seeing that a lot of normal people. Now the perception of the normal people can change from my point of view or your point of view or doctor's point of view. So that's how, as a data scientist, you can contribute. Okay, so there are, if you go, at least go for the public health domain, so there are a lot of contribution is there. I mean, a lot of statistician is actually working in that direction. And as a statistician, you will find there are a lot of way you can contribute actually in the betterment of the society, and where your work will be valuable, and it's a high stake game. So if you are a good statistician, you can contribute a lot, And if you are a bad statistician, you can damage an entire generation. Okay, so it's up to you. How do you want to use your knowledge? Okay, so now we'll talk about the multiple input values. So let's copy and paste this one. So earlier, because sometimes you may need to predict many values. So what I did here, I defined another point. Okay, so let's the new dot x dot 1. Okay, age is here, earlier was 61, 956, and 18, male non-smoker. Okay, now I combine those things, R bind. So R bind means that row bind. Now print AA, if you write here, this is the, so you have now two data sets. If you can do for each two, you can put many data, new data as you want. And now do the same thing as you've done earlier. Here. Okay. So here, just run that one. So it will give you the prediction for the first one. So we have already seen this one earlier. We have already seen this one, and this is for the second, that is 56, 18, male non-smoker. Okay, and definitely you can see that because the age is higher, your prediction of this FEV is 2.71, and that is actually job for a statistician. You see the data, you already connected to the interpretation. It's not about just feeding data and stop your work. So you need to infer about. The more you infer, you will be regarded as a better statistician or a data scientist from the customer point of view. Okay, so that is done. And for the copy and paste to you, because right, dev.off. Okay, now again I'm writing that one. Okay. You can do all the other stuff that you wanted to do here. Yeah, UQ plot is there. So here now we'll talk about the jackknife. So that is the outlier. Okay, so what it does, go back here. So here one by one, that will help you. Okay, jack. Yeah. So from the R students who are using this one, I'm trying to save all these jackknife residuals here. And finally, out of, so let's check that what is in the jack. So this is all the jackknife residuals are there. And this command will say that which of the jack residual is the maximum. So I'm taking the absolute value of the jackknife residuals, and then the maximum value is 4.75 corresponding to the 624 observations, and range of this, let's check. So range is minus 0.339 to 4.75, and this is the maximum one. Okay, so now this, if you put the sorted one, this is the from the sorted one, the minimum is there first, and then so on. And if you go back for the tail one, so you are coming here with the highest 4.75 here at the end. So now Bonferni critical value. So this is another, there is a concept called like, am I using this one? I don't think, no. So this is actually multiple testing problem. So when you are testing many testing statistical hypotheses, then you should check for the multiple testing problem. But I should not go. That's a huge topic that cannot be covered here right now. So what we are doing here, okay, so here I am calling the regression line here exactly same regression equations, but only I am running on the subset like Jack. Okay, so this is like if the jackknife residuals. So based on this data, I have already calculated the jackknife residuals. If the jack is less than maximum of jack, then only I run this regression. That means that I am removing that point which having the maximum value of the jackknife residuals, and then calling the summary here. Let's check that one. So if you remember that, that means I removed 1 point. Okay, and you can see that there is no such change with respect to R square. That means that even though it is considered very, very large value of the maximum jackknife, that is not changing anything. So I can ignore that as a outliers or leverage points kind of thing. Okay. So, but if you feel that this is changing too much, then you can think about that whether this is outlier or not, and then you can talk to the concerned person what is going on, and then decide whether to remove that value from the dataset or not. But please do not delete the values from your end just by you think so, something like that. And also for the cook distance here, you can get these plots wherever want. Okay. So there are again warning. Let's check that one. Far away. Okay, cook's distance. What is the problem? So I have not shared all those things to you. What I have shared. This one. Copy paste. Yeah. So cook distance is there. Plot. One plot is there. Another plot is there. So you have seen already all those plots, and you zoom it. So these are the cook distance, and you can decide whether this is leverage point or not. And the good way is to check that similar again. So I'm fitting the regression line with the same data and same model. Only thing that I'll consider a subset of this data. So I'll only consider those points which are less than the maximum. That means I'm removing the point with maximum cooked distance. Okay, and if you do that things again, and let me. I'm not able to decrease this one. Something is wrong. Okay. It's not wrong. So again, the R square value is 0.77. That means removing this point is not changing the R square value too much. So that means that that point is not having any substantial potential to become a problematic one. So I can leave that one. Okay. Okay, so we are also done with these things, and only one thing is left, that is the any questions up to this? Otherwise, we'll go to the Odin's data. Okay. Seems like everybody is understanding everything. That is exactly what we want. Okay. So the last one is the logistic regression, and for that one, I have already shared one data set. So that data, Odin's data, is already with you, right? Is that right? The Odin's data with you? Hello?
Yes, sir, we have
okay.
Odin's data. Yeah.
Okay, thank you very much. Okay, so this data is also available in this library called the faraway. Again, faraway is something warning message is there. So I will call this directly, but if you do not have the data, so you can read, so you have already know how to read the data set. So you just copy this kind of things. So you need to read .csv and the file name, and then assign that to O-rings data. So whatever you have to write there, so let me write that for you. O-rings. Yeah, I mean, read.csv. What was the name of the dataset? What was the name of the O-rings? That or something else? CSV. Let's try that. Yeah. So it's already there. Print that one. Perfectly all right. So I can copy this one, paste, so that you can read the data from your end. Okay. And then I'll check the data. STR, that is a structure. So that will give me that there are 23 observations and 2 variables, and both of them are integer. One is temperature and another is damage. So if you look at the head of this data, so this is the head, temperature and damage. And if you want to plot, this is the plot of the data that you have already seen earlier. Okay, so this is the highest maximum 5 damages out of 6 damages. And these are the 1 damages and these are the 0 damages. So far so good. And then if you want to check this, so table is a good command, particularly for the damages. So here it will give you the idea that with respect to 0, how many damages, with respect to 1 damages 6 times, 5 damages only 1 times. So let me copy that one so that you can run all these commands from your end. Okay, so let me save that one. Let's plot this one. So this one, what was this one? Yeah, so this is the probability of damage and temperature, and we are forcefully trying to fit a linear model there, and that was the command to run that one. It will give you a straight line fit there, and for the logistic model fit, you will just need to copy and paste here. So you need to run this one. Yeah. So this is the output. Okay. So here, as I explained earlier, so cbind is the column bind, but if you have a just binary factor variable, you just replace this one with y. That will work for you. And this is calling the binomial family from binomial family, and basically the default link is the logit link, so it will fit the logistic regression there. And these are the coefficient, and null deviance is there, residual deviance is there. So whenever there is a decrease, that means your model is actually working, and AIC is 33.67. Okay, and then what else? Again, I have plot. I need to increase this size, otherwise.
So why we have used a damage by 6 or 6 minus something damage?
Damage. So it is a binomial random variable. So generally, whatever, if you see the variable, so y is like 0, 1. Okay. here, if you see that, let's go back to there where we have printed table. Yeah. And head. So here, there is no problem with the temperature. Temperature is the input variable or X. The damage is not binary like 0, 1. This is actually, it can take any value 0, 1 to 6, right?
Yes, yes.
Okay, now the logistic, so most of the examples, I purposefully included this example to give you a feeling that it's much more like 0, 1. Even if your outcome is not 0, 1, but as long as it is following binomial distribution. Here, the variable damage follows a binomial distribution with binomial n is equal to 6, and there is a success probability p. P is the probability of damage. Okay, so that means that you will have a 6 trial. You are just thinking about, if you are familiar with the coin tossing, that means you are tossing the coin 6 times and you are observing number of heads. Here you are having a 6 different trials, or you can, the maximum up to 6 damages can happen, and you are observing how many number of damages happen. So in the first case, there are out of 6, 5 damages. In the second case, only 1 damage out of 6. And in the fifth case, there is no damage, only 0. Okay, so here when I'm fitting here, so the R code is written in such a way that if I put that, so they need the Y minus N minus Y. If you remember that when I gave the examples in the morning, so you need to put the Y and N minus Y. N is the 6, that is number of maximum attempt here. Here out of 6, there are 6 O-rings or something like that. And I'm trying to, how many of them already damaged? So damage minus 6 damage. So if you print this one, so what will print? Head. Yeah. Gain some. See my damage. Oh, it will not take because the data sets is not there. I don't know whether it will print like that. So what was the name of the data set? Codings. It first print that one. Heads. Oh. I don't know whether it will work. If it is work fine, then otherwise we have to do something else. Yeah, perfectly working. Okay, so what it will say that with respect to that damage, so for the first observation, damage is 5, n minus 1, n minus damage is 1. Similarly, here we have only 1 damage, that means damage variable is 1, n minus y damage is 5. So all these cases, your sums has to be 6. Okay, so this is the format that are want in this particular topic, but if you use something else software, this may not be the case. So this is the way someone has whoever wrote this GLM, they actually prefer in this format. So this is nothing like rocket science. So somebody wrote that function for you and he preferred to be in that way. Okay, so that means if you run that one, so does this clear your confusion? Or you are more confused after my explanation? Okay, so this already we talked about, that one. Then there was a plot. Okay, so this is the plot. Let me share the command first with you. So up to this, I have shared to you. Let me share this command so that you can. Okay. So I run this one again. No, I have the plot. Okay. big size, otherwise I'm not able to see all those things. So look at the logistic fit here. This is the logit fit. I mean, so probit is something problem. I was working on something else. You just ignore this one. Only the logit. This is the only one line here. So look at, so when the temperature is high, we expect that we will have less number of failures, almost like 0 or 1. So when temperature is moderate, we are having like this kind of failure. And when the temperature is like less than we expect, there is only one observation, and based on that, so this is a small data problem. We don't know what will happen with the large data, but this is the fit. That means from this fitted model, if I assume that this model is perfectly correct, then I can expect whenever the temperature is small than 50, there is a high chance that there will be a failure based on the data that we have. And you remember, we are trying to focus that whether the 31, the temperature, 31 Fahrenheit, that means we expect a very high probability of failure there. Okay, here damage is success. That means success probability is very high. And that exactly what we observe in case of. Okay, so if you want to add a legend, you can do that. I just copy for you. I will not run that one. Okay, and the last thing is that you can predict. I also copy and paste for you. So just run this one. Yeah. So that based on the 30 degree Fahrenheit, so and these are the estimated model parameters, and your prediction of the success probability that in damage is 99. It's pretty much high. Then so it was that almost sure that you are expected to have a explosion because of the low temperature. So these phenomena could have been diverted if this analysis was done at that point of time. So that was pretty much all. So you have learned all those things. Hope you will be confident enough to the things from your end. Okay, so some of you already know. So as I promised, I will show you something to show the power of R. So let me go back whatever one of my summer students developed. So let me search my name here, Google Sites. Yeah, so this is my web page. You can visit sometimes. Okay, yeah, COVID-19. I was working on the COVID-19 there. So my few students developed a Shiny app. Okay, so yeah, this app is loading, and this app is developed by two of my summer intern last year. So this app is not, I mean, I'm not updating the results on regular basis. I stopped last year after October or something, but this will give you something that it is entirely based on R, and from anywhere all over the world, you can see this graph. So this is uploaded in a server, and just if you click the case history here, so it will automatically give you, and it was last updated like September or something like that. Okay. So this was like how the first case in each of the associated happened in each of the states, and you can select a specific state and like say for example, Assam here.
Sir, right now, sorry to interrupt, but right now we can only see your R studio screen.
Okay.
If you go on another screen, sir.
Let me stop that one. Okay. Share. Yeah, thanks. Otherwise, I told too many things. Okay, so let's go back to can you see right now?
Yes, sir.
Okay, so this is this. So you can go to my webpage, and this app will be there. And if you click here, it will upload for you. There's small animation. You should be able to see the animation from the Indian map. This is the how actually first case came into the each of the states. Okay, and if you select any specific state, for example, that time like Assam or something, so all the information are there, so it will be there. That time it was long back, so after because of the data issues I was not updating, but this app is extremely flexible. So this is one of the measure, and if you just do this kind of things, then you can see how the things are going on. And if you put the cursor here, you will see this, there things are changing. What is the value of these things? And if you see the look at this area when I'm changing the cursor value. So it is extremely flexible. If you can see the zoom it, you can zoom it. So these are give you a feel that what you can do actually. So this is called Shiny app, entirely based on the R software. But this needs a lot of dedication. My student gave them. So these are Arjo Das and Pritam Sil from Jadavpur University last year. They are IT students there. Okay, so this is pretty much done from me. Let's stop this hearing from here, and then I'll listen from you. Okay. I don't know what I have any minutes. Can you hear me?
Yes, sir.
Yes, sir.
But my screen is something like that. Okay, can you see me also? I don't know, my camera is working. Okay, so something from my end. So I'm pretty much done. So was it useful to you, all these whatever three things, that simple linear regression, multiple linear regression, and the lab session that I covered for you?
Yes, sir, but I think some hands-on practice would be required to grasp more knowledge, but otherwise it was very useful.
Yeah, hands-on, because this is a like capsule thing. So a lot of things are covered in a very short span of time. And the objective is to do that just to motivate. So as a teacher here, my job is very simple. I just need to motivate you to do the things for you. And as an individual, your job is much more simple than myself. You just need to motivate yourself. You don't need to motivate else one. Okay. So let me close this one.
You will share these code files.
Yeah, I'll definitely do that. Something is going on. I'm closing, and then I'll again log in. Can you hear me?
Yes, sir, we can hear you, but your video is not visible.
Right now, it should be visible to you.
Yes, sir. Visible as well as audible.
Okay, fine. So as I said that my job is pretty much simple, that I just need to motivate all of you. I don't know whether to some extent I was able to, I was successful or not. And your job is even simpler. You just need to motivate yourself, and that is pretty much simple. So that you have these slides, and you have the I will send the all the codes to the Professor Sairam, and he will send it to you, so that you can some other point of time you can practice all of them. And if at least some of you are motivated enough and do the all those things from your end, that will be extremely helpful or extremely satisfying for me. So if you I am done. So if you want to share any of your feedback, I will be happy to listen. Anyone of you want to say something? Good thing, bad things, I'm okay to all.
Hello.
Yes, is this?
Yes, sir. Sir, this is Prem Vaswani here.
Yes.
Very interactive session, sir. Thank you for all the knowledge you have shared. Sir, one general query I had, I wanted to ask you, when we assess the R square value, And we sometimes we find R square
Can
too
you
high.
please put
Like
your video on? If it is
Yes,
not a
sir.
problematic, so
No,
that
no,
I
no.
can. If it is network problem, then it's fine. Otherwise, it's better to put the video.
Yeah, sir. Maybe network problem will
Okay,
be
okay,
there.
problem. Go ahead, please. You are talking about something about R square.
Yeah, so sir, if R square value is coming too high, and we say if it comes around 0.9 or 0.99 something, so we sometimes say there is a problem of overfitting. So, sir, what is the limit where we describe that the model is overfitting or it is a good model? So, where we can distinguish between a good model or an overfitting?
So, what do you do?
Sir, I'm a research scholar, sir.
You are a research scholar. In
NIT,
which area?
sir, economics.
Economics. So, how much money is good for you?
Sir, we can't answer that question, sir.
Why you can't answer that? I'm asking how much money is good for you.
Sir, for some people, little bit is good, and for some people, unlimited is not enough.
Okay, that is the answer. For some people, it is something, and for some people, something. Exactly, that is my answer. For some cases, it depends on your context. Some cases, 0.8 is good. Some cases, 0.9 is not good. So everything, I mean, it is like a context, what you are exactly doing. So even for the overfitting, you need to check with respect to other data sets, like how it is performing well. But in a real life problem, if you are getting R square value of 0.99, I will be very much suspicious about the data. So that means that it's almost like a perfect relationship. Anything more than 95 is very much suspicious to me, because in general, real life things are not that normal. Okay. And people talk about the normality. I mean, whenever I get normality, I am very much suspicious, because normality in general, in real life data, if you are generating from the computer, that's fine. If you are related to a software, something like, but if it is a real life data, then it hardly follows normal. I do not see many things which exactly follow normals. So whenever I get the R square value like more than 0.5, I'm very much suspicious that something is fishy there. Okay. So because there are a lot of variability, a lot of other factors cannot explain. So whenever you are getting more than 95, that means that your input variable or predictor variable can exactly predict the other one.
Yes.
And yeah, that is not expected from real life situation. Okay. So hardly you will get something like that.
Okay. Sir, one more thing. If we when we talk about the hello.
Yes, I can hear you.
Yeah, sir. When we talk about these deep learning models, new methodologies are there, like random forest and all other deep learning models are there. When we apply these methods in data analytics, we generally get R square value about 0.9. Especially in random forest technique, we generally get the R square value of 0.9 above. So can we say that it will be suspicious and model is not good enough?
Just a minute. Yeah. So you are saying something. Go ahead, please.
Yes, sir.
Yeah. So you are saying that. Can you say something about what the deep learning model you are getting? Yeah.
Sir, I was saying like if when we use deep learning methods of like random forest or decision tree models in data analytics, we generally get a high R square value of about 0.9. So can we say that?
So in the somewhere, are you using the R square like regression setup or something else?
Predictive analysis, sir. In predictive
in predictive analysis, are you using the regression inside your entire model setup?
No, sir. No.
No, then generally a lot of people use R square, but I do not recommend until otherwise you specifically using regression line, specifically linear regression. You should not consider R square. Okay. So what exactly your problem there. So you need to think about that. So I mean, suppose you are classifying something or you are predicting something. So instead of doing like R square, you just plot that whatever the values of the actual observed and your plotted value, whether how much difference is there, whether that is there. If you are talking about the classification, what is the actual accuracy rate, those kinds of things should be checked. And you should not concentrate only one measure only. One measure can sometimes blind you about the accuracy of the problem. So it will look from the different measure and take a wise decision.
Yeah, definitely, sir. Definitely.
Okay, thank you. Anyone else?
Yeah, thank you, sir.
You are welcome. Anyone else wants to share anything, or otherwise we'll close this one?
Yeah, someone was asking for if there's any good book, Palash.
Okay, where? In the chat?
Yes, yes.
So, good book means good book related to regressions you are talking about. So I generally follow that Montgomery book, and I have already given in the reference list. But for the book, what I generally suggest to my students that no good book is good for everyone. So I may like one book, but because of my training and all those things, which I may find very easier for me, might not work for you. So you search on the internet, you follow the different books, 2-3 books, whatever books is comfortable to you, start with that. Once you are master with the subjects, all books will be equal to you. But if you are starting for the first time, then you should start with which is as simple as possible and understandable to you. Okay, so do not take which is good book for me and just blindly follow that book. So explore all those things and take one textbook that is working for you. But if you go with that, I already mentioned 2 books that I followed, and you can check all those books. So Montgomery book is a quite traditional book for the linear regression, and there is another book by Chatterjee and something that is also a little bit in a lucid manner, and you can check that one also. Yeah, I think that is all from me. If there is no questions, we can close this session. Thank you, everyone. I enjoyed talking to you, and I learned a lot of things from you, which is very much valuable. And thank you all once again.
Thank you, Palash. Thanks a lot for all the decisions. Okay. So to the participants,